Welcome to our calculus notes for 2.6b. Today we're talking about related rates and specifically related rate word problems. So in number 1, it says how fast is the area of a rectangle changing if its width is 1/3 its length and the length is decreasing at 5 feet per minute when it is 12 feet long. Let's go ahead and draw our diagram here. So we have a rectangle and here's its length, and we know that the width is 1/3 its length. Okay, so if we're using our dreads, here is our diagram. Now we need our rates. So we know that the length is decreasing, so that's going to be dl over dt, and it's decreasing at 5 feet per minute, so that's -5. And what we're trying to find is how fast the area is changing. So what we're trying to find is dA over dt. Now the stipulation is we want to know this rate when L equals 12. All right, so we're going to get some equations here. So one, we know the area of a rectangle is length times width. Now remember, our equation is going to be based on the rates that we have. Okay, we have the rate of length and the rate of area, and so our equation should also have length and area in it. Now we want to rewrite this in terms of just length and area if possible. So right here we can see that W equals 1/3 L. So we're going to rewrite this as area equals length times 1/3 L. And then we'll simplify. So area is 1/3 times the length squared. All right, so that's our first goal, is get that equation in terms of the two rates that we have, length and area. Now we know a rate and a derivative is the same thing. So we're actually going to derive this. And this is the D step of our dreads. So we want to find the derivative of A with respect to time. And that means we're going to derive the other side, which is 1/3 L squared. And so we already have the derivative with respect to t solved by itself. And so this derivative, we're going to use the power rule. So it'll actually be 2/3 times L to the first power. But then we need to remember to multiply using the chain rule. So the derivative of L with respect to t is just dl dt. All right, once we're here, we're going to use our knowns and substitute. So let's come up here and substitute. So we know we're looking for dA over dt, and it's going to equal 2/3 times L, and we're going to use the L equals 12 right here. And then times dl over dt, which is -5. So when you simplify this now, we're going to get -40, and we're going to add our units of feet squared per minute. And that is the rate of change of area with respect to time when the length is 12 feet. So it's actually decreasing by 40 square feet per minute.